All right, today we're going to take a look at real-world domain and range. So remember, domain is your x values from left to right, and range is your y values from the bottom to the top. We'll be re-looking at things we've covered previously, so if you get lost on any of those things, please go look for the previous videos to get those in more detail. For example, if you can't do this part, please go to write an equation given context. So, for example, Kai was given a gift card for a coffee shop. Each morning, Kai uses the card to buy 1 cup of coffee. So think about that for just one quick second. And always put yourself in this situation, but when you write the answer, use whatever name they gave you. So I have a gift card. Well, if I'm buying coffee, what's happening to the balance of that gift card? It's going down, right? So if I'm going down, my balance is going to start at 40, but it's going to keep decreasing. In order to make it decrease, it means that the number that keeps happening has to be negative. Okay, so each cup of coffee costs $5. So I'm going to subtract 5 from 40 every time I go to the coffee shop. And the original amount of the money on the gift card was 40. Okay, write a function for A in terms of C, representing the amount of money remaining on the card after buying C cups of coffee. So remember, C is my input, what I'm putting into my equation, and whatever is after the equal sign is my output. Remember, my input is my independent variable, the one that doesn't depend on anything, and my output is my dependent variable, meaning I'm waiting to see what my input is in order to see my output. Okay, so remember, I'm always thinking in terms of my 8th grade work, which is y equals mx plus b. But we're writing it in function notation, which means we're going to transfer it into 9th grade language. But the process is the same, it's just that it's in function notation. So we've got the name right here. Now we need the slope. The slope is what keeps happening. So what number keeps repeating? As I go into the coffee shop, there's a number that keeps happening. And if you read this question carefully, it says, I start off with $40. Then every time I go buy a cup of coffee, it's minus $5. I buy a cup of coffee, minus $5. I buy a cup of coffee, minus $5. I buy a cup of coffee, minus $5. So therefore, the number that's repeating, my slope, is negative $5. Now, we're not going to put X like we did in 8th grade. We're going to use function notation, and it tells us in this case little lowercase c is the number of cups of coffee that I'm going to buy. Then we're going to go with plus b. What did I start with on my gift card? I started with $40 in the positive. I was not negative $40, I was $40 in the positive. Again, this is just a quick recap of what we've done previously. If you are going to have problems with this part of the question, you want to go review the video of writing an equation from a table using Desmos. All right, so I'm going to quickly put it in, and again, if you find that I'm going a bit too fast, that's the video you want to review. All right, so go ahead and type in the function just like you see it. Please make sure that you copy it correctly, because one of the biggest mistakes is that you might forget a 0 and it will change everything. All right, so please make sure that you're copying exactly what you have on your paper. So now that I have my function, how do I make it a table? Remember from previous videos, you're going to hit settings, then table, and that's going to be the table. Now I'm not going to write all these values down, but I am going to press enter. It looks like I need till 8. So you come down to the last number, press enter all the way down. So go ahead and copy those values in, or put in the table for yourself, which will be even better. So these are the values that go right here. And then how would I get negative 65 on this side? Because right now I have 50, 45, 40. So it's going down, but how do I get up to negative 65? What you do is you just keep, there are 2 ways. You can press enter until you get to negative 65, which might take a while, but there it is. So that's the answer for that. Or you can come right here and use the graph. So I want my y, my output, to equal negative 65. So I'm going to say my output is equal to negative 65. And then all I have to do is go to the graph and see where it intersects. So there should be another line somewhere. There it is, where it intersects my original line. And I don't like that they're both black. So what I'm going to do is come right here. And you can long click that dot and change the color. So you see one is red, one is black. All right, so this is where they meet. This is to hide that. So I click that, and there is my number. So the same number that was in my table. 2 different ways of doing the exact same thing. So I'm not going to write those values. You go ahead and pause the video, or rewind the video, and write that in there. So 135, I have 230, 325, 420, 515, 610, 7, 5, 8, 0, And I do have negative versions. So I have negative 145, negative 250, and then I have 9, negative 5, 10, negative 10. All right, so I've put in my coordinates. But this is, notice in the title, it says real world domain and range. Real world, okay? In the real world, let's just think about this. I have a gift card. I have money in my gift card, okay? And then I'm just using this money to buy cups of coffee. I'm going to start right here. It says name the X and the Y axis. Well, I have money that's going down, which makes sense, going down. And then I have cups of coffee that I'm buying that's going up. So my X axis is cups of coffee. C, cups of coffee. I'm going to try not to write in this box because I'm going to need to write there. And then here I have my money on my gift card. So dollar in gift card. Okay, so now just think about that for a quick second. If I'm looking at money and gift card and cups of coffee, okay, you're going to cross out the values that don't make sense in the x-axis. So what would not make sense in terms of cup of coffee? Can I have 1 cup of coffee? 2, 3, 4, 5, 6, 7, 8? Can I have 9 cups of coffee? No. Why? Because I'm going to run out of money. So this portion of my graph does not make sense. So I'm just going to highlight it as it's crossed out. All right, what about, can I have 0 cups of coffee? Absolutely, I didn't spend any money. How about negative 1? No. So these coordinates here also don't make sense because we're really in the real world. Now we're going to look at the y-axis and cross out the values that don't make sense. So remember, my y-axis is the amount of money in the gift card. And I've already crossed this out because could I have $45 in the gift card? No, because it said I had $40. So that's crossed out anyway. And then can I have $40? Yes. Can I have 35? Yes. Can I have 30? Yes. Can I have 25? Yes. Can I have 22? Yes. Can I have 15? Yes. Can I have 10? Yes. Can I have 5? Yes. Can I have nothing on my gift card? Absolutely. Can I have negative 5 on the gift card? No, it'll just stop working. So these have already been crossed out. And that's what real world does. All right, so read the definitions in this and decide which qualifies. We've talked about all real numbers. Remember, that's every number you can think of, fraction, decimals, radicals, anything at all. Non-negative real numbers. So every number you can think of, fractions, decimals, all of that, except they are non-negative, which means they're positive. So only positive. Oh, and it says that in the definition. All right, real numbers between two numbers or two constraints. So everything you can think of, decimals, fractions, radicals, in between 2 points. Whole numbers, a whole number that is simply any positive number that does not include a fractional or decimal part, including 0. So I just want to highlight the difference between whole numbers and integers. All right, so whole numbers are basically any positive number that's not fractions or decimals, but it also includes 0. So that means 0, 1, 2, 3, 4, 5. Integers, however, also have no decimals or fractionals, but they can be negative as well as positive and also include 0. So basically, whole numbers are 0, 1, 2, 3, 4, whereas integers are negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3. So they have the negative piece attached. If I say positive integers, I'm really talking about whole numbers, which are 0, 1, 2, 3, but I don't include 0 because 0 is neither positive or negative, so I'd be 1, 2, 3, 4. Integers between two numbers. Okay, so this is a number with no decimals or fractional part from a set of negative or positive numbers, including 0, but between 2 points. And then this is where we've kind of talked about before, but I know we may not remember, so I definitely want to go ahead and emphasize. Continuous function is with a line representing continuous values. So that means that it includes the decimals, fractions, whereas a discrete function with discrete and separate values does not connect the dots because it doesn't include the in-between parts. Okay, with a line due to either, so it doesn't have to necessarily be both, but either x or y being a decimal fraction. And we're going to talk about what that means in here. So my question is this continuous? Can I connect these dots between here and here? So let's think about that for a second. We're going to start off with looking at the y-axis. Can I have, let's say I was right here, 9.9. Yes, I can have $9.90. So I can connect the dots in terms of y. All right, so let's look in terms of x. So remember, it has to be both, right? All right, can I have 1.5 cups of coffee? Can I buy 1.5 cups of coffee? No. So because this one is not allowing me to have a decimal or a fraction, I cannot connect the dots at all, even though the y-axis is allowing me to have a decimal or fraction. So this is not continuous, but it is discrete. So discrete, because I can't buy half a cup of coffee. Okay, and that's really it. So that's the difference between connecting a line and not connecting a line. Okay, so now that we know that, we're going to do the range. So range is the y values from the bottom to the top. So you can't include this because this is the real world. So what's the bottom? The bottom in terms of the y-axis is 0. So it goes from bottom, this is the bottom right here, to the top, which is 40. We cannot include these because that's not part of the graph. So from 0 to 40, but we're going to use now definitions. So I'm looking for between 0 and 40, I'm looking for what? I can have decimals, right? Yes. So I'm looking for anything in between 0 and 40 because I can have decimals in dollars. So I'm coming here, all real numbers, everything I can think of, no, because I have to start at 0. Non-negative real numbers, okay, that's true, but I can't have 50. Okay, real numbers between two numbers, yes, that's actually what I'm looking for. So everything I can think of between 0 and 40. So that's my range, real numbers between 0 and 40. And remember, because we're talking about range, we're going to use y. Can I include 0? Absolutely. So because I can include 0 and 40, I can go ahead and write it like that. Now I'm going to take a look at the domain. So remember, the domain is from left to right. So all the way on the left, yes, there are things here, but I can't include that. So I'm going to start here. And I cannot go further than 8. But now be careful, I cannot have 0.5. So this will not be real numbers because real numbers includes decimals and fractions. So I'm not going to even read anything real numbers. I'm going to start right here. Whole numbers, a whole number is simply any positive number that does not include a fractional or decimal part, including 0. Okay, so I can include 0 and it's any positive number that does not include. So yes, it's 1, 2, 3, 4, 5, 6, 7, 8, but I can't go 9. So this is not going to work. It could be an integer, but we don't have negative. Positive integers, whole numbers not including 0. So this one does include 0, so that's not it. Integers between two constraints. A number with no decimal or fractional parts from a set of negative or positive numbers, including 0, but between 2 points. So I can actually write this as integers between 0 and 8 inclusive because it's closed on 0 and 8. So that's what I'm going to write. So that's integers. And this is the x-axis. So we're going to use the x value. So you can see here you have the option of x and y. So integers between 2 points. And we're going to say x is in between 2 points inclusive of 0 and 8. So we're just kind of changing a little bit of what we've been doing so far to include real world, because real world sometimes does not include everything, so we do have to account for that. You're going to do example 2, and here's a hint for you, okay? There is no graph in example 2, so what I need you to do is write, then type the equation into decimals. So once you write the function right here, right, type it in decimals so you can see the graph. Go ahead and sketch the graph, so you can sketch it on the side right here if you have space, or on the bottom, anywhere really is fine. So sketch it on paper and label the axis, just like we did here, label the axis. Then answer what is x in context, what is y in context. In other words, for me, x was cups of coffee, y was dollars and gift cards. Ask if you can have negative zeros, decimals, etc. So I kind of just walked you through that on the y-axis and on the x-axis. Then read these definitions to decide which one it is. And then tell me what is the range, what is the domain, and what is the range. And also complete example 3 using the same steps. But now, in addition to that, I'm just going to check some previous work we've done. Can you tell me h of what? The input if I tell you the output. And can you tell me the output if I give you the input as well as your domain and range? Let's practice.